All right, hello, welcome to Lab 9. We'll be doing suitability analysis, which is a raster-based analysis process that you use primarily in land use planning, but you can use it for all types of things. In this case, we will be using it for a land use planning example, and that will be identifying the most suitable habitat cores and the most suitable corridors between those habitat patches for mountain lion in Southern California, and a highly developed area of Southern California in the mountainous region. So it's based on an Esri tutorial, and the first thing you need to look at the top is this lesson plan. And the lesson plan will outline exactly what you'll be doing. You start by identifying what's the best habitat, you'll prepare your data, you'll actually build your first model, which is a suitability model. The second model, again, calculating those corridors between the suitable patches, and then you'll spend a few minutes kind of evaluating what you've come up with and what that means. That's the big question, right? So you've come up with your analysis, you have your answers, and then so what? You also get an estimate from Esri here about how long it will take you to run through each section. I do think this is a reasonable estimate of the time as long as you don't get sidetracked. If you stay focused and try not to make too many mistakes, it's a very reasonable estimate that you'll finish within a few hours. A couple tips, and they mention this in the lab. I just copied the text so that you know where it is. So right at the top, they'll say, okay, if you're going to make a mistake partway through, we don't want you to get caught up with that mistake trying to troubleshoot where it was, because with model building, that can get pretty complicated. So they provide you all of the intermediate steps and all of the intermediate outputs. So if you do get stuck, can't find out what it is, go ahead and look in that geodatabase for their intermediate product. You can go ahead and slap that into your model and you don't have to start from the beginning. And then another thing is that these two models you'll be building, they have examples of that in the results toolbox if you need to just refer to that as an example. You have to go ahead and create your own for your project, but you can refer to them if you need a little guidance. All right, you will store everything in this Mountain Lion Corridors toolbox, the geodatabase. It's all very organized, and that's very important when working with any data, but particularly raster data. Again, you'll start out with this setting the environments option. Okay, very important. Okay, so what is the input into this suitability analysis? We want to identify what are the most suitable areas, create a surface there. That can help us identify the areas that we want to prioritize for conservation in general because they're the most suitable. And then we also want to create a corridor between each of these patches so that they're all connected. That's important for metapopulation dynamics. So that's what we want to get out of it. We have 4 inputs, okay? The land conservation status, this first raster, it's like, what is the protection status? Is it protected? Is it not protected? How protected is it? We have land cover. That's if it's developed, maybe it's grassland, maybe it's forest, maybe it's barren, maybe it's a lake. So that's your land cover, and it breaks it down into those different land cover types there for you. You have elevation, and elevation alone is not necessarily what you want. You want ruggedness, right? You want a very rugged mountaintop type of habitat. That's what mountain lions really like. And so that's what you'll end up analyzing out of the elevation. You'll get a ruggedness metric from that, and that's what your elevation input will be. And then the last input will be roads. And again, not necessarily roads themselves, but some metric based on roads, in this case, distance to roads. So kind of like a buffer, but the raster version of that. So again, this is just copied from the text so you know where it is. You'll use these 4 criteria, ruggedness, land cover, protected status, distance from roads, and calculate some metrics from some of those because you don't want necessarily just the original data, and then you'll need to reclassify some of it. And then once you've put all of that together, you will put all of this in a model, get it into the right format that you want. Is it originally elevation, turn it into ruggedness, for example. And then you'll need to reclassify all of those. You'll need to put those into classes, maybe from 0 to 3. That way they all add up to, you can add them all together and get the right suitability out of it. And then you'll put them into a weighted sum tool. And that pretty much adds all of it together with different weightings because some factors are more important than others, right? Like for example, ruggedness and land cover might be the most important, so you might weight those more heavily. The tutorial will walk you through that process. They're great explanations. Then you'll come up with the suitability surface. That's one of the outputs from this lab. And then the next part, you'll create another small model that will be your corridor analysis. And that's where you pretty much create a cost surface. So it's like, how much effort is it for a mountain lion to cross a certain raster cell? And then that's given a value, a weighted value based off of that. And then it runs the shortest distance between 2 points, considering the cost that it is to move across that surface. So it might route the mountain lion around a different direction based off of what the land is like. Okay, so that's what these corridors will look like here when you're completed with the project. You'll have the 3 primary corridors in between each of these 4 habitat patches. And the habitat patches are given to you, but you'll see that they actually exist within some of the most suitable habitat, at least for these 3 outer ones. And this Santa Susana one maybe is a little bit less suitable because it's inside of these more developed urban areas, but it's an important habitat patch nevertheless. So you'll be asked to, at the end, again, evaluate your results here, see what you come up with, and just think about it a little bit. And of course, you'll create 3 map outputs. Okay, so now that we've gone through the introduction to the lab material, I want to show you how you might get started with this lab. Very straightforward, okay? Go to the Lab 9 page, and I've given you a template. Go ahead and download that template. I've opened it here on the left. Lab 9, there are a couple important things. So you need to first open this Esri tutorial, okay, right here at the top, and that will give you that will take you to the tutorial page. So this should look familiar now. You know, you have this lesson plan, scroll down, and it starts you out with the directions. Make sure you download and extract the Mountain Lion Corridors folder. It will walk you through that process, but you're already pretty familiar with it. A lot of the steps that are in the beginning will be familiar to you at this point. It's kind of designed for someone who might just be getting started with this tutorial. Very straightforward. Another important thing to consider, I put it right here on the top. You have this View Final Result button. That's great. That is not just for viewing the final results. Let's go ahead and open that, see what it looks like. Okay. This is actually kind of a story map format of walking through the lab, explaining everything and why you're doing it and what the implications are. So we scroll down, we get the background. Okay, what is the story behind trying to identify this mountain lion habitat? Why would we do it? It walks you through why it might be a problem, explains to you in simple terms what a wildlife corridor is. They show you a nice analysis here based off of this process. They walk you through all of the methodology, okay? Just kind of what I explained in the intro just now, except, you know, in a written format. And then what all those different inputs are. And of course, this is a story map, so it's a really nice format. Gives you an explanation of what each of the different inputs is. All right. So there will also be a link to the video that you're watching now, just in case you need to get back to that at any time. And I put this template together because you don't have a quiz format for this. You will just be putting everything in one document. We have a rubric on Canvas, so it's easy for you to do, easy for us to grade. Very, very similar to a quiz. It's just in a document. So go ahead and just enter your answers in here. So what were the 4 criteria used? Go ahead and enter your answer, and then put your, name this document with your last name and upload it to the lab page on Canvas. Note that there are 3 different map layouts, each worth 10 points. I would do your best because maps are where people tend to lose the most points on their quizzes, or at least on their lab assignments. So make sure you put a lot of effort into that, and you could just use the same general layout for each one and put the different data in there. Okay, Esri tutorial is very straightforward. Once you get to the end, don't get to the end and then forget to answer some of the questions that we have here in the template. So what were the criteria used in identifying, list the 2 models, and then You have to answer here, which of the corridors would you prioritize for conservation, give an explanation. And then there's a question here that you should include on the map of question number 6. What's the best location for constructing a road crossing? Okay, so just as you're moving through the lab, make sure that you answer those very basic questions as you're moving along. And that's it.